Aerobic respiration starts with one glucose molecule and 6 oxygen molecules. They react in a complex 4-step process that I want to illustrate for you by means of this animation. The first step is called glycolysis, and the background of this animation will stay pink throughout that first step. In glycolysis, the glucose molecule is split in half, some of the atoms rearrange, and 4 hydrogen atoms are liberated from the molecule. In the end, this results in 2 new molecules called pyruvic acid molecules, 4 individual hydrogen atoms, and some energy. Notice that nothing happened to the oxygen molecules at the top. That's because this step is anaerobic, which means it doesn't need oxygen. Alright, let's move on to the next step of the process. The next step is called the formation of acetyl coenzyme A, and I'm going to color the background of the animation yellow during this step. Notice we still have 6 oxygen molecules up at the top. That's because they haven't been used yet. We have 4 hydrogen atoms from glycolysis. And we also have 2 new things, 2 coenzyme A's. Where did these guys come from? Well, they're not a part of what we consider the necessary components for aerobic respiration because they're produced in one respiration and used in the next. As a result, the net effect is they're neither used up nor produced. They simply cycle through respirations. What do these guys do? Well, they go react with the pyruvic acid molecules. They cleave a hydrogen from the pyruvic acid molecules, liberating carbon dioxide, and they attach to what remains. The result is 2 new molecules called acetyl coenzyme A's, 2 carbon dioxide molecules, and 2 more hydrogen atoms. Although a lot of chemistry takes place in this step, no energy is produced. That's the end of the formation of acetyl coenzyme A. Now we're ready for the next step, the Krebs cycle. I'll keep the background of the animation green during the Krebs cycle. The Krebs cycle is the first step that uses oxygen. 3 of the oxygen molecules that we need for aerobic respiration come down and interact with the acetyl coenzyme A molecules. This breaks the molecules apart, liberating the coenzyme A's, producing carbon dioxide and hydrogen. In the end, this produces 4 more carbon dioxide molecules, 6 more hydrogen atoms, 2 coenzyme A's, and some energy. Now remember, those coenzyme A's will be used in the next aerobic respiration, so we don't really consider them products. They're just going to get used up again. Alright then, we're almost done. We just have to get through the last step, which is called the electron transport system. During this step, I'll keep the animation's background blue. In the electron transport system, the 12 hydrogen atoms from the previous steps interact with the 3 remaining oxygen molecules. This results in 6 water molecules being formed. That's the end of aerobic respiration. So what did aerobic respiration make? Well, it made 6 carbon dioxide molecules, it made 6 water molecules, it made some coenzymes for the next respiration, and it made a lot of energy. In the end then, aerobic respiration simply takes a glucose molecule and 6 oxygen molecules and makes 6 water molecules, 6 carbon dioxide molecules, and a bunch of energy. Remember, even though they're listed here, we're not going to consider those coenzyme A's products because they're going to be used in the next respiration step.